Hey, grade nines. Today we are going to do a lesson on similar triangles. Okay, so this goes hand in hand with the last lesson that we did on similar polygons. And it's important for us to know that a triangle is just a special type of polygon. So the same kind of rules apply here. There's nothing all that new. If we want to see that two triangles are similar, we have to take a look at the same kind of thing we looked at to make sure that two polygons are similar. So the two things that we're going to look at are, we're going to look to see that the measures of the angles are equal, or the ratios of the lengths of corresponding sides are equal. Either way, one of those two things is going to help us determine if two triangles are similar. Okay, so good enough. Let's go ahead then and take a look at some notation and get into some examples. So here we have triangle ABC and triangle DEF. You can see that the triangle on the right is a lot bigger, but if we took a protractor and measured the angles, we would find the following. We would find that angle A is equal to angle F. We would find that angle B would be equal to angle E. And we would also find that angle C would be equal to angle D. Okay? And that's if we took a protractor and checked those angles out. Okay? Now, what we also know to be true is if we take a look at the lengths of the sides, and if we take a look at the lengths of the sides, then we are going to see that basically corresponding sides are all proportional to one another. Now you might be thinking, okay, English please. Okay, well, if I'm going to put this in English, allow me to say this. What I mean by that is that if we take a look at, say, the side AB, now AB is going to correspond with, looking at this, it's going to correspond with EF. Now, what we know is that AB is shorter than EF, right? We can see that. We can see that AB is shorter than EF. But there's going to be some kind of ratio between these side lengths. Like, for example, AB could be half as big as EF, okay? Could be half as big. And I'm using half because it's a nice number, okay? Likewise, we could say that BC and DE correspond in the same way. Like BC would be half as big as DE. Finally, AC would be half as big as DF. It doesn't have to be half, it could be a third, it could be 2/3, it could be 3/5, it could be any number we want, but the idea is that the yellow highlighted sides, the green highlighted sides, and the blue highlighted sides all have that same ratio, okay? So either the sides are proportional to one another, or all the angles are the same. And when we know that, then we can say that the triangles are similar, okay? And that's the topic of today's lesson, is similar triangles. And more importantly, what we can say is triangle ABC is similar to triangle FED. Triangle ABC is similar to triangle FED. Now, when we write out the similarity statement, order matters. So what do I mean by order matters? Well, let's look back at our triangle here. In our triangle, we can see that angle A is equal to angle F. So the first letter mentioned in this triangle is A. And because F is the same as A, F is the first one mentioned in the second triangle as well. And we keep going from there. B is the second angle that's mentioned. So E is the second angle that's mentioned, B and E. And by process of elimination, C jives with D. So C is mentioned last, as is D. It doesn't matter which letters come first in the first triangle. You could call this ABC, you could call this ACB, you could call this BAC, BCA, CAB, CBA, call it whatever you want. But the order in which the letters appear in the second triangle is dependent on how you named the first one. If A comes first, then the letter that corresponds with A has to come first over here, and so on for second, and so on for third. The other thing that's important is when we're taking a look at this, we also see how we write out the statement. We say triangle, and that's what that little triangle symbol means, is triangle, ABC, and then we use this little squiggly to represent similar. Triangle ABC is similar to triangle FED. Okay? Triangle ABC is similar to triangle FED. Okay? That's how we say that two triangles are similar. So if you're asked to make a similarity statement or to state the two triangles that are similar, this is the ultimate statement that you have to make. But before you get there, you have to make sure that either all the angles are the same or the sides are proportional to one another. Okay? Let's do an example. And this is a great example to do because it says to identify the similar triangles. There's no angles given, so this should be a giveaway that instead of using angles, we're going to have to use sides. So we're going to have to look at sides. We're going to have to pick sides that correspond with one another. Now, to make this easier on yourself, I would do it this way. Go the biggest divided by the biggest. So if we take a look at the first triangle, the biggest side would be 12. Second triangle, the biggest side is 4.8. So we're going to go ahead and divide those two and see what we get. So we're going to go 12 divided by 4.8, and that's going to give us 2.5. That's our ratio. So that means that sides on the left triangle, if the two triangles are similar, are 2.5 times bigger than the sides in the right triangle. To make sure that this ratio holds for all pairs of sides, we have to do it for the other two pairs. So we started with the biggest. Now we'll go to the next biggest, which is 10 and 4. So now we'll go ahead and go 10 divided by 4, also get 2.5. Now that isn't a dead giveaway. We still have to do the last pair. And of course, the last pair is 7.5 and 3. So we're going to go 7.5 divided by 3. And that also gives us 2.5. So that verifies what we saw with the first pair that sides in the triangle on the left are 2.5 times bigger than the sides in the triangle on the right. And because we get this same number, 2.5, 2.5, 2.5, that is the ratio. And that's the same all the way. So that tells us that these two triangles are similar. So now we can make that similarity statement. So we can say that triangle, so we could say JKL, and we probably would say JKL just because it's in alphabetical order, is similar to triangle. Now, J, which would J correspond with? Well, the way to figure this out is J is the intersection of blue and green, blue and green. So the intersection of blue and green over here is N. So J is going to correspond with N. So N comes first. K would correspond with M. And L is going to correspond with L. So the similarity statement is triangle JKL is similar to triangle NML. That's how we identify similar triangles. Okay? Okay, now let's do a word problem. And here's our word problem. Matt is standing beside a building. Matt is 5 feet tall and casts a shadow of 3.2 feet. He's standing beside a building that's casting a shadow of 11.2 feet. How tall is the building? So we have Matt, and we have a triangle. Let's see here. Okay, that's 5 feet. That's 3.2 feet. And then we have a building. So we have a building. There's our building. And then we have this. We know that this is 11.2 feet. And we want to figure out the height of the building. So how are we going to use similar triangles to do this question? Well, what we need to do is we need to find the scale factor. That's what we need to do. We need to find the scale factor. And in the last question that we did, we saw that the triangle on the left was 2.5 times bigger than the triangle on the right. 2.5 is the scale factor. So we have to find the scale factor here and then use it to find that height. So the sides that are going to be a pair would be the shadow lengths. The shadow lengths are the 3.2 feet and the 11.2 feet. So we're going to go ahead and divide those. So we have 11.2 divided by 3.2, and that's going to give us 3.5, which means that the shadow for the building is 3.5 times bigger than Matt's shadow. So it would also stand to reason that the height of the building is 3.5 times bigger than Matt's height. So our next calculation will be Matt's height, 5 feet, times 3.5, and that's going to be 17.5 feet, and that is your final answer. So in this question, we are looking for what the scale factor is. It's 3.5, and then we're using the scale factor to find the height of the building. So once you have your drawings figured out and you know what you're looking for, it's a two-step problem. Find the scale factor, find the height. So if you include the drawing, it's a three-step problem. Drawing, scale factor, and then height. Okay? Okie doke. And one more example. A shipping company sets up a ramp to help workers bring freight into a building. There is a support in the middle of the ramp. Find the height of the support. So what we want to do here is we want to create two similar triangles. So the first similar triangle is going to be this one right here. And the second one is going to be the big triangle here. So the first triangle, we know that this is 12 meters. We don't know what that is. That's the height of the support. That's what we're trying to find. If we draw the entire triangle, we know that this is 5 meters. Now this is the trickiest part of this whole question. What's this? Now, when you think about what this is, some might say it's 8, but it's not 8. Here's why it's not 8. This much is 12, but then we're going this much plus more. So common sense would say that it has to be more than 12. So it has to be more than 12. So 8 doesn't make sense. But 8 more than 12 does. So what's 8 more than 12? 8 more than 12 is, of course, 20 meters. And now from here, we can use scale factors to find the height of the support. Okay, so let's go ahead and use our scale factors. Most times it makes sense to take the biggest thing and divide it by the smallest thing. So the length of the ramp here is 12. The length of the ramp here is 20. Those are corresponding sides. So it would make sense to go ahead and divide those numbers together. So 20 divided by 12. If you figure that out, it's going to be 1.66666 repeated. Leave that number on your calculator. It's going to be 1.666666667. And we're going to take that number and we're going to multiply it, or actually, sorry, no, we're not going to multiply it. Here's why. Because what we know is this, the height of the support, is going to be less than the overall height. So it doesn't make sense to multiply it by 5. We know it's going to be smaller. So we have to keep that in mind. It's going to be smaller. If we multiply that 1.666666666 by 5, we're going to get a bigger number than 5, and that doesn't make sense. Instead, what we're going to do is we're going to divide 5 by that. So actually, we won't be able to keep that number on our screen. What we're actually going to type into our calculators would be 5 divided by 1.66666666666. And when we do that dividing, we're going to get 3 meters. So the height of the support is 3 meters. Okay? So in this question, we had to draw two separate triangles, and it's very important to draw those triangles so you have an idea of what the situation is here. Once you draw those triangles, label them, figure out your scale factor, and then multiply or divide, in this case divide, to get the correct answer. Your practice questions are on pages 349 to 351. Try them and make sure to reach out and ask for help if you need it.